Welcome to Math Success Seminar Online. I'm going to talk about algebra. So, what is algebra? It's basically a way of maneuvering numbers and a way of finding numbers that can really benefit from figuring a problem out. So in this first one, if I say 2 plus what makes 10? 2 plus what makes 10? Maybe you already know. You would say, well, if I add 8 to it, that'll become 10. All right, let's hang on to that. Now this one I'm saying 2 times what makes 10? 2 times some number that we don't know right now makes 10. But you can figure it out if you know your multiplication tables. You're going to say, well, that number is 5 because 2 times 5 makes 10. So this is a way of eyeballing how to do algebra. But let's actually dig into how it works. So in a problem like this, what is the goal? What are we trying to do? We're trying to isolate the variable. What is a variable? Well, there could be many variables. It's pretty much any letter. In this case, it's x. It could have been a, b, c, x, y, even Greek letters sometimes like theta or omega. I don't know. Pretty much a letter represents a variable. So we want to isolate the variable. How do we do that? Here's where order of operations can come in. If we're adding 2 to the variable, how do we undo addition? We undo addition with subtraction. So this addition subtraction part, these go together. Multiplication division go together. These I just pair together. They don't. This is more of like an order. Parentheses first and then exponents. So if we're adding 2 to x here, the first thing we want to do, get out of here, is we want to subtract 2. Since we're adding 2 here, we want to take 2 off. But there's an equal sign, and everything that we've been dealing with up to this point hasn't really had an equal sign in it. Here is where algebra is very important. Using order of operations on one side each, since there is an equal sign, you can think of it like a scale. So if I'm taking 2 away from this side, I need to take 2 away from that side to make it balance again. So 2 away from here, 2 away from here. 2 minus 2 is 0. 10 minus 2 is 8. Since we're adding nothing to x, this is pretty much just telling us that x is equal to 8. So this is the technical way to do it. I recommend doing this when you have very large numbers. I chose 2 and 10 for an easy example. What if it was like 54 and 36? Then this is the surefire way to do it. Now, when you have 2x equals 10. So we already answered this one. 2 times what makes 10? Well, we know the answer is 5, but how do we know the answer is 5 other than knowing multiplication tables? How are these two bound, 2 and x? 2 times x, this is bound by multiplication. So how do we break multiplication? We break it with division. So if these two are being multiplied together, that means we want to divide this side by 2. If we divide this side by 2, we have to divide the other side by 2. 2 over 2, 2 divided by 2 makes 1. 10 divided by 2 makes 5. Since we only have one x here, you could also write it like this. X equals 5. Because this is just implied that it's a single x anyways. It's kind of like saying How many cars? Do you have a car? Yes, I have a car. You could say I have one car, but you only talk about numbers when you have more than one of something, I guess. But this is how you would deal with multiplication. So now the other style of that, what if we have x minus 3 equals 7? So a number minus 3, so if we have a number and we take 3 away from it, we'll get 7. So how do we find this number? Well, how are these two interacting? Remember, the goal is to get x alone. So it's x minus 3 is 7. So since this is subtraction here, how do we break subtraction? With addition, the other side of the coin. Meaning I want to add 3 to this side. If I add 3 to the left-hand side, I have to add 3 to the right-hand side. Remember, this is kind of like a barrier between the two sides. Negative 3 plus 3 makes 0. So all we have left is this x. I'm going to bring it down. 7 plus 3 is 10. So 10 minus 3 is 7. This is how to deal with subtraction. And then the last one I'm going to show really quickly is an example of division. So x divided by 2 equals 10. So some number, if we divide it by 2, we're going to get 10 out of it. So remember, the goal is to get this alone. So this is hanging on to it. How is it hanging on to it? It's hanging on to it by division. How are we going to break division? With multiplication, the other side of the coin. Since we're dividing by 2 right here, what I want to do is I want to multiply by 2. But if I multiply this side by 2, I have to multiply that side by 2 also. This way, 2 divided by 2 becomes 1, leaving just the x down. 10 times 2 is 20. So these are very simple one-step problems. And this is how order of operations, parentheses, exponents, multiplication, division, addition, subtraction. This is how you can use them to solve a problem that has a variable in it. So, in short, what makes an algebra problem? Two things, I think. There's an equal sign, first off, and there has to be a variable. If there's no variable, then there's no algebra problem to be done, and it's just like your normal order of operation problem. But again, throughout the course, we're going to return to, or you're going to see a lot of algebra in different forms. You're going to see algebra with more than one step. These were all one-step problems. You might see 2 or 3, or even in a big order of operations problem with an equal sign hanging onto it. And you're going to see it with fractions. So we'll cross that bridge when we come to it, but this has been kind of a small overview, but I'll catch you next time on Math Success Seminar.